Okay, this is the components weld. So yesterday, we talked about cleaning up the ends of these, and what we did on the belt sander was we beveled or chamfered these edges and knocked down all the burrs. This is a not cleaned up edge, so if you look at all the nasty stuff there, we don't want to weld on that. Plus the mill scale is the dark gray coating, we don't want to weld through that. So we cleaned these two ends up because we're going to weld them together. We squared them as best as we could. And now we're going to fixture them into something and weld them together. The first thing I would advise for you is to flip your helmet up, Olson. You don't need to protect yourself yet. Helmet flood. Normally, if the tables are clean, you can use the tables as a tool here. This is a broke edge, meaning it was sheared, okay, and these edges were bent, and we can use them to line up material. If we put these together and line these up so they were flush all the way along. The problem is the tables are fairly spattered from welding, and they haven't been cleaned down. Don't sand right now, Anderson. That's good that you're ambitious, but really? First the pencil and now the sanding? What's with the noise making? Okay.
That's funny because
so,
that's in the video too.
This table's not clean. If it was clean, we could use it as a tool. We could maybe find a clean edge, but instead we're going to just grab a piece of angle iron and we're going to use this as a guide. And this works awesome. You just slap this in here, pull these together, and as a precaution, we will clamp these down to the table, just so they don't move. We want to make sure that they don't actually cause this stuff to move. So we're going to hold it in, clamp it tight, go to the other side, loosen the back of the clamp until we get the right amount of resistance. No gap there. I'll leave a little gap. No, I don't want to. Actually, the ends could be beveled more, just so there is some room, because there's really almost no room there, but that's okay. It's tight. We'll weld it through. Front of the welder, turn it on. That's working. I'm going to set it for pretty much the max thickness because this is 14 gauge. I've already measured this yesterday. But because it's cold metal and I'm just starting the weld, I want the maximum voltage possible. I'm going to take my ground clamp, hook it directly to my source just to make sure that it's hooked up good. Turn the gas on. Check the flux capacitor. Looks like I got about 15 pounds, which is good. I've got too much wire and no side cutters, so I'll just clip it off again there. Oh. The nozzle's kind of dirty. Check it out. Who was welding with that thing? Oh. So if we had a pair of pliers, we'd use that. Otherwise, we're going to find a sharp corner of a piece of metal. Perfect, but it'll work. Helmut, would you please? Thank you, John. Turn it on. Probably do that too. Those of you who don't have one on should not stare at this. Kukowski doesn't have that problem right now. I'll say cover, and I'm going to put a spot weld right at that joint. I'll put another spot weld at the base. Cover. Let it cool a little bit. I'm going to unclamp after this is cooled. I got two spot welds on the back side. Move that boat a little bit. I can't really clamp it like this because they're in the way. I can clamp it like that. You can see it's bowing a little bit because of those welds. It actually pulled them. So I might be able to pull that out using clamps.
Alright, it's going to be that long or are you going to have to go sharpen?
Yours will be like a minimum of about 6 inches a piece. Cover. Good. So I'm going to go around this now all the way. Cover. Roll it. Cover. Weld right through my spot welds on the third side. And fourth side. That's heat right there, but that's good. You got a lot of heat in there. It's pretty straight. So what I'm going to do here is knock this down. I don't need to take all that weld away. If it's a good weld, leave it. Everybody wants to grind it down to nothing. If it has to be ground down because this has got to be flat, then take it all the way down to the flat surface. But if it doesn't, I want to see that, okay? There's nothing wrong with that, and that's totally presentable. What I'm gonna check for is straightness of it. So I'm gonna hold it along a material edge like this and look, see if it's straight. It's good that way. I don't know if you can look down this. If we look down this, the gap is pretty much equal. I've got just slightly off, probably an 1/8 inch out. And this way, it's good. So how do I test this? I'm gonna take it over to the scrap barrel. And I'm gonna get it up the edge. If it breaks, I know that it was poor, okay? If it doesn't break, I know that it was good. Normally,
is that considered breaking?
No, this didn't break. It'll crack. Most of yours will like crack in there. You'll be like, oh. If it cracks on the first swing, that's a D. Second swing, C. Third swing, B. Fourth swing, or if it doesn't crack, it's an A. Okay. I progressively hit it harder. Yeah. The first time I'm just like, oh, you got a D. Good job. C, B. I crank on it, and then A if it holds on. The weld should be the strongest part of the material because it should be thicker than the material itself. So we got a pretty good weld here. What you would do after this is you would chop this off in the chop saw. I haven't demonstrated that yet. And if there's a straight section here, which it looks like there pretty much is, chop that off and reuse it. Just get rid of your weld joint, okay? But I'll test it for you. Any other questions on this?
Do we do the circles?
Do you do the circles? What do you mean? Yeah, like I was making a pattern here to make the butt weld wider, cover more material. Yep.
So bend it back.
Any other questions?
Can you bend it back?
Okay, and scene.